Good morning, guys. Welcome to today's lesson. We're looking at the sequences and series, the sum of an arithmetic progression. This is lesson 3 in these lessons. Of course, this is for the IB Mathematical Studies program. Okay, so quickly, just a reminder, of course, on arithmetic progression. We know that it is a linear pattern, which means that we have a common difference of D. Hopefully remember that if we need to show that it is an arithmetic progression, we show that U2 take away U1 is equal to U3 take away U2, or that there is a common difference. Okay, we also learnt last lesson that if we want to find the general term, so any term in a particular pattern, we simply take that first term of U1, and when we do n take away 1, times it by that common difference. And that was a formula that we are given on that formula sheet. Okay, so what are we looking at today? Well, if we look at an example, I think we've done this one before, 5, 7, and 9, okay, where we have a U1 of 5 and a difference of 2, we might now be asked, because of course that is our sequence, we might be asked to add them together, 5 plus 7 plus 9, okay, which is now becoming a series. And of course it's an AP series. Now of course if I had 5 plus 7 plus 9, I'd just say that's 12 plus 9 is 21, okay, and I'll get my answer and I'll move on. But of course we might be asked to find the sum of the first 20, the first 100 numbers in this particular series, which obviously can be quite challenging. So what I'm going to do, I'm going to break this one down like I did on originally for the first lot, okay, when we're looking at the general term. So if we had 5 plus 7 plus 9, which of course we have our U1, our U2, and U3, what we have got, and as I said, I can show you the actual way that we do that. We have our U1, we have our U1 plus our difference, our U1 plus our difference plus our difference. I might actually throw another one on there, plus 11. We have our, I'll put a little pluses in the middle there, our U1 plus our difference plus our difference plus our difference. Now that's theoretically what I've got, right? Which means I've got 1, 2, 3, I've got 4 lots of U1s plus 1, 2, 3, 4, 5, 6 lots of D's. Now if I took a common factor out of that, let's say we take a 2 out, okay, we're left with 2U1 plus 3D. Now what you might notice, you may or may not notice, is that I've got 4 terms and I've got this 3. And so we're going to come up with a rule, and now this is just kind of showing you where the rule came from, very, very briefly, I guess. But this rule you're given, which is S of n is equal to n on 2, brackets, 2 lots of U1 plus n minus 1 times D. And I'm just guessing that you're kind of seeing how this works. We had 4 terms here. 4 over 2 is 2. We've got 2 lots of U1, we can see that. And then n minus 1, well 4 minus 1 is 3, we've got that as well. That's the first formula. Now we're also given a second formula that we can use, which is Sn equals n on 2, we'll call it U1 plus Un. Basically I say that is the first term and that is the last term. Now you might think, well, okay, how does that kind of work? Alright, well, what I can show you is if U1 plus UN, well UN, we found that as a general rule earlier on, okay, last lesson, n over 2 plus U1, we learnt that UN was U1 plus n minus 1 times D, and then also you got this U1 plus U1, which is the 2U1 n minus 1D. You can kind of see where it comes from. But I guess for us, we just need to make sure that we know what those two formulas are. This will allow us to very quickly add up all these terms together. Okay, believe it or not. And of course they are on our formula sheet. So if I apply that to this particular question, okay, Sn equals, well, 4 divided by 2, and I've got 2 lots of U1, so 2 lots of 5, plus 4 take away 1 times a difference of 2. We can say that that's 2. 10 plus 3 times 2 is 6. That's 16 plus 2 equals 32. And of course, if I add this together, 5 plus 7 is 12, plus 9 is 21, plus 11 is 32. We can see that they're the same. If I wanted to use the other rule, of course, we've got Sn equals our n on 2, which is 2. Our first term is 5. Our last term is 11. 11 plus 5 is 16 times 2. Still going to be 32. Okay. So what do you need to be able to do? I guess that's often the question that we want to ask. So first of all, the two things that I want you to get out of this lesson is to learn both of these formulas. N over 2, un, sorry. So the first term, or u1, plus un, plus the last term. Once again, that's the first term, and that's the last term. Now that's given to you if you have the first term and the last term. We can do that. If we don't have a difference, we can get around that. The second rule works if we do have a difference, which is our 2 lots of u1 plus n minus 1 times the difference. Okay, and depending on the question you get, will depend on which one of these two that you might use. All right. So let's have a look at 2 questions and see if you can do them. So again, you might want to pause these, folks, and have a crack at it and then come back to it. So I've got 5 plus 7 plus 9 plus ... Find the sum of the first 10 terms. Example 2, I'm going to give you 5 plus 10 plus ... plus 100. And I'm going to say find the sum of these terms. That last one's quite tricky. Okay. Hopefully you've had a crack at that. If not, pause it now and please have a crack and see what you can come up with. The first one, well, first of all, I know that it's an AP. How do I know it's an AP? Well, I know that 7 take away 5 is 2. I know that 9 take away 7 equals 2. Therefore, there is that common difference. I always like to write that if I'm not told it's an AP. Find the sum of the first 10 terms. So my sum of the first 10 is 10 over 2, brackets, 2 lots of the first term, plus 10 take away 1 times the difference, and the difference we've always said is 2. And put it in your calculator, get the answer. I don't have a calculator, so I'm just going to do it a little bit slowly. 2 times 5 is 10, plus 9 2s are 18. 10 plus 18 is 28, and 28 times 5, what's that going to be? 140. Beautiful. Okay. The last question here is quite challenging, of course. You might have played with that and said, hold on, there's an issue here. I know what my difference is. The difference is going to be 5. We can get that. Once again, that comes from that 10 take away 5. We can't really show that this one is an AP because we don't have more than one to kind of compare to. Therefore, I would have had to have told you in the question that it is an AP. But the problem is going to be here is that if I look at my 2 formulas, now obviously we do have a difference, so we can use the first, or we had the last one as well, we could use the last. But either one that I use, okay, whether it be the first one, so I'm just going to write it out so we've got it there, 2 lots of u1 plus n minus 1 times d, or s of n equals n on 2, u1 plus un. The issue is both of these, we don't have an n. We don't know how many terms that there were, and that's a bit of a problem, right? So what's our solution? Well, our solution is that we have a formula that can help us to find the last number of terms. So, for example, we can find, it's a bit hard to see that one, we can find out, using this rule here, un equals our u1 plus n minus 1 times d, we can say that the last term is 100. And what we can actually do is now solve this, put our 5 in for our first term. We're going to solve this for n. And it's times it by, it's going up by 5, isn't it? We can solve this for n. So what I'm going to do now, I'm going to put a line down there. I might use white actually. We've got 100 equals 5 plus 5n minus 5. Well, 5 take away 5 is 0. So 5n equals 100. N equals 20, which means there are 20 terms in this sequence. So now I can go back to either one of these. Because here I've got my D, I can put it in and say equals, so this is S20, equals my 20 on 2 times 2 lots of 5 plus 20 minus 1 times 2. Or I could even use this one, which is probably a little bit quicker. S20 equals 20 on 2, the first term, which is 5, my last term is 100, okay, which is going to be 10 times 105, okay, which is going to be 1050. In either case, you should have got that as your answer of 150. Okay, now that was significantly more challenging than the previous two questions, but certainly one that we do see coming up time and time again in terms of the sums of an APs. So I guess once we look at the end of that, it's just what do we have to know out of this lesson? Okay, well, we need to know the rules. Sn is equal to n on 2 brackets. We have our u1 plus un, which is the first plus the last term. Or, which is probably more commonly used, n on 2 brackets 2u1 plus n minus 1 times d, and that will allow us to find the sum of a arithmetic progression, or better, an arithmetic series. Okay, remember, arithmetic, linear, and common difference. I hope this made sense, guys. I hope you found it useful. Any problems, drop me an email. All the best. Have a great day.